Welcome back to Mrs. Thompson's classroom. Today we're going to continue with law of sines, and we're going to figure out when can we use it and when can we not. So the first thing we're going to do is we're going to start by reminding ourselves of what the law of sines tells us. It tells us that for any triangle, the ratio between an angle and the side opposite that angle is consistent for the entire triangle. Oops. Okay, so what that's going to allow us to do is solve triangles and find all the sides and all the angles. And so we're going to start with a triangle like this. Now this is a case of angle, side, angle, because I know two angles and I know the side in between. Okay, so let's see how this works. Let's set up our ratio. I'll have A over the sine of 55. I'll have B over the sine of 25. And then I'll have 10 over the sine of angle C. Okay, so as we start, every ratio has an unknown. So we think we may be stuck. However, any triangle adds to 180 degrees, so that I know angle C is 180 minus 55 minus 25. Right? So 180 minus 55 minus 25 gives us that angle C has a measure of 100 degrees. So I now know this one. Okay? So now I can replace this with 100 degrees. So now I have a ratio that is fully known. So let's start with 10 over the sine of 100 and set it next to the A over sine of 55. If I multiply the sine of 55 to the other side, I get A is 10 times the sine of 55 divided by the sine of 100. And I can plug that into my calculator. We don't have sine of 55 memorized. And we get A is equal to 8.32. So I now know side A. Okay? Now, if this was a right triangle, we could use Pythagorean theorem at this point, but it is not. So now I'm going to set that 10 sine of 100 next to the ratio with side B. And I cross multiply. And I can find side B. And we get 4.29. So if I know two angles and the side in between, law of sines works nicely. Okay, let's try another one. Now this one is angle, side. So I know two angles, but the side that I know is not between them. Well, let's see if that works. First of all, again, we know we can find angle C. The measure of angle C is going to equal 180 minus 48 minus 20. So if we do that subtraction, we get 112 degrees. Okay, so now when I set up my ratios, I have 8 over the sine of 48 is equal to B over the sine of 20, and that's C over the sine of 112. So by using this first ratio that is fully known, I can show that B is equal to 8 times the sine of 20 divided by the sine of 48. And C is going to equal 8 times the sine of 112 over the sine of 48. So then we plug that in. And we find that side B is 3.68. and side C is 9.98. So what we've discovered is if I know all three angles and a single side, any side, law of sines is going to work. Okay? Now, what happens if I know two sides and an angle? So let's say we know these two sides and we know the angle in between them. Now, if I only know one angle, I don't have a way to automatically know what the other two angles are. So my ratio would be C sine of C. So let's say this is 50. A over the sine of A, and let's say A is 6. And then let's say B is 8. So none of the ratios are fully known. I have to know one of the ratios completely in order to use it. So if I know side angle side, law of sines doesn't work. Okay? Also, if I know side side side, well, none of the ratios are going to be fully known because every ratio requires an angle. So I have to know at least one angle. So this one doesn't work either. Okay. Now there are a couple of other cases. One in particular, if we know all three angles but no sides, well, we know from geometry class that does not make a specific triangle because you would just can expand it and get similar triangles, but not congruent ones. So that's not going to help either. Okay, so for right now, we can do angle, side, angle, and we can do angle, angle, side. So take a minute to practice these problems, and then we will see you next time where we're going to expand to one final case of law of sines that actually is what we call the ambiguous case because it can actually have two solutions. And so we'll see you next time for the ambiguous case.